Ever since the existence of exoplanets was discovered, humanity has wondered how many habitable planets there are in the universe that could have all the key ingredients for life to thrive. Thanks to the now retired Kepler Space Telescope, an answer to the question may finally be in reach. New research suggests that there may be no less than 300 million planets within the Milky Way alone with the potential for liquid water. Let's take a look at these new findings. These new findings come as a result of data collected by NASA's planet hunting mission called the Kepler Space Telescope. The retired mission consisted of an observatory in space dedicated to finding planets outside our solar system, with a particular focus on finding planets that might resemble Earth. The observatory was in commission for just under 9 years, from its launch in March 2009 to its decommissioning on November 15, 2018. Since Kepler's launch, astronomers have discovered thousands of extrasolar planets, or exoplanets, through this telescope alone. Most of them are planets that are between the size of Earth and Neptune. In the early days, an important part of Kepler's operations was eliminating false positives. Because apparent star dimming can also take place through means other than exoplanet transits, each candidate planet was confirmed through other telescopes, generally by measuring the gravitational wobble exhibited by a star in response to a revolving planet. But Kepler's original mission was not so much to identify individual exoplanets as it was to take a census of as many stars as possible and estimate the percentage of stars that host planets. So, as Kepler accumulated experience, statistical methods were brought into play. For example, in February 2014, astronomers pioneered a new technique called verification by multiplicity, which distinguishes multiple planet systems from multiple star systems and thus finds many exoplanets at once. Through this technique, the team unveiled 715 confirmed planets in one release, making it the largest batch of planets in a single announcement up to that time. Thanks to Kepler, we now know how common it is for other stars to have planets. Over the first 7 years of the telescope's operations, NASA issued 24 press releases announcing newly discovered exoplanets, often in large batches. The final release data from Kepler's primary mission came in June 2017. Kepler's confirmed planetary finds were boosted to 2,335. Including potential planets, the total count stood at 4,034. During the entirety of its service, the telescope surveyed more than 500,000 stars. Thanks to these outstanding achievements, scientists were able to collect enough data to study for decades to come. Recently, this data has helped astronomers uncover that there may be more than 300 million planets with the potential for supporting life in the Milky Way. Some of these exoplanets could even be our interstellar neighbors, with at least 4 potentially within 30 light-years of our Sun, and the closest likely to be at most about 20 light-years from us. These are the minimum number of such planets based on the most conservative estimate that 7% of Sun-like stars host such worlds. However, at the average expected rate of 50%, there could be many more. This research helps us understand the potential for these planets to have the elements to support life. This is an essential part of astrobiology, the study of life's origins and future in our universe. To calculate this occurrence rate, the team looked at exoplanets between a radius of 0.5 and 1.5 times that of Earth's. They also focused on stars similar to our Sun in age and temperature, plus or minus up to 1,500 degrees Fahrenheit. That's a wide range of different stars, each with its own particular properties, impacting whether the rocky planets in its orbit are capable of supporting liquid water. These complexities are partly why it is so difficult to calculate how many potentially habitable planets are out there, especially when even our most powerful telescopes can just barely detect these small planets. NASA estimates that the Milky Way is home to around 100 to 400 billion stars. Every star in the sky probably hosts at least one planet, meaning there are likely trillions of planets out there, of which we have only discovered and confirmed a few thousand. A lot of factors influence whether a planet can support life, including its atmosphere and chemical composition. But to narrow down the trillions, the researchers in this study focused on a few basic requirements. They looked for stars similar to our own sun in age and temperature, so it wouldn't be too hot or active. They also looked for exoplanets with a similar radius to Earth and singled out those that were likely to be rocky. They also took into consideration each planet's distance from its star. Too close and the heat could vaporize any water, too far and any water could freeze. A habitable planet needs to be in the just right zone, or the so-called Goldilocks zone, to support liquid water on its surface. According to NASA, previous estimates of the number of habitable planets did not reflect how a star's temperature and energy could be absorbed by its planets. But this time, scientists were able to factor temperature into their analysis thanks to additional data gathered by the European Space Agency's Gaia mission, which is charting a three-dimensional map of our galaxy. The data from the Gaia mission allowed scientists to look at these planets and their stars in an entirely new way. After analyzing the data and performing calculations, researchers used a conservative estimate that 7% of Sun-like stars could host habitable worlds. However, scientists believe this rate could be as high as 75%. We all know how special Earth is, all the world around us, the planets and moons in our solar system, and this is the only habitable planet, bountiful and wondrous. Life, as we know it, was birthed here and has since sustained, thrived, and transformed the global ecosystem, and also became far more complex, intelligent, and technologically advanced. And therefore, when scientists say they are looking for Earth-like exoplanets, they are looking for conditions similar to what we have here on the blue planet. And part of what makes Earth a habitable planet is a biochemical process called photosynthesis. It's the process by which plants use sunlight, water, and carbon dioxide to create food and to release oxygen into the atmosphere. This is critical in enabling complex biospheres of the type found on Earth, and for an exoplanet to be potentially habitable, therefore, it means it would develop an oxygen-based atmosphere. New research has found that the planets that are both Earth-like and have just the right temperature for liquid water to exist on the surface are much less common. None of the several known rocky and potentially habitable exoplanets have the theoretical conditions to sustain an Earth-like biosphere by means of oxygenic photosynthesis. The study, which looked in detail at how much energy an exoplanet receives from its host star, found that only one, Kepler 442b, came close to receiving enough sunlight necessary to sustain a large biosphere like Earth. Discovered in 2015, Kepler 442b is a rocky planet about twice the mass of the Earth that's orbiting a moderately hot star around 1,200 light-years away in the constellation of Lyra. It is a super-Earth exoplanet that orbits its host star at a distance of about 0.409 astronomical units and takes 112 days to complete one orbit of its star. The scientists calculated the amount of photosynthetically active radiation received by a planet from its star and discovered that stars around half the temperature of our Sun can't sustain Earth-like biospheres. This is because they do not provide enough energy in the correct wavelength range. Oxygenic photosynthesis would still be possible, but such planets could not sustain a rich biosphere. Planets around even smaller and cooler stars, known as red dwarfs, couldn't receive enough sunlight to even activate photosynthesis. Stars that are hotter than our Sun are much brighter and emit up to 10 times more radiation in the necessary range for effective photosynthesis than red dwarfs, however, generally do not live long enough for complex life to evolve. Since red dwarfs are by far the most common type of star in our galaxy, this result indicates that Earth-like conditions on other planets may be much less common than we might hope. These are just some of the factors due to which a presence of water on an exoplanet does not guarantee that it may be an ideal host for life to thrive on its surface. Over the coming years, scientists will continue to study the remaining data from the Kepler Space Telescope, which may lead to even more exciting discoveries about the habitability of planets in our galaxy. If you like the video, please consider taking a look at this one on NASA's TESS mission, which may have found 2,200 exoplanets that could sustain life. Do you think there is extraterrestrial life in the Milky Way? Please share your thoughts in the comment section below.